All right, for notes 49, we're going to start graphing quadratic equations. And there's 4 different problems, so I'm going to make 4 different videos because these videos can tend to get a little bit long because there's a lot of bits, parts, and pieces rolling around. So first things first, we have our lovely quadratic equation right here. It is in the format that we want it to be in. So we've got this ax squared plus bx plus c form, which is what we're looking for. And I'm going to be looking for all of these critical features to graph, and then we'll talk about the domain and range after we've done the graphing. So the first critical feature I'm going to look to find is actually not part A, it's going to be part B. And the axis symmetry is a little equation here. You're going to find it by doing x equals opposite of B over 2A. And the reason we care about the format that this equation is in is so that we can get this B and A value. So let's see what we got here. X is equal to the opposite of B. Well, B is 2. So the opposite of 2 would be negative 2, all over 2 times your A value, which is the coefficient for x squared, and that's going to be a 1. So that's going to be negative 2 over 2. So your axis symmetry is going to be x equals negative 1. All right, so that's the axis symmetry. Now, axis symmetry is the line, it's the line of symmetry that your parabola or graph has so that the 2 sides of the parabola match. Whatever's on the left side will match up exactly to what's on the right side. Now, the fun part is that now that you know your axis symmetry, you actually know half of your vertex. So for the vertex, we know that the x value has to be negative 1. For the graphs that we're doing, your vertex lies on this axis symmetry. So this x value has to match that x value. But the problem is your vertex needs 2 parts. I need a y portion here. So what we're going to do is we are going to evaluate your graph here, your function, using x equals negative 1. So everywhere I have everywhere I have an x, I'm going to replace it with a negative 1. So little evaluating here, negative 1 squared is 1. 2 times negative 1 would be minus 2, minus 8. That would be a grand total of negative 9. Yeah, negative 9. Took me a second there. All right, so that is the vertex. So now that we've got the vertex, we've got the axis symmetry, let's talk about finding some zeros. Okay, so for the zeros are better known as x-intercepts. And the way we're going to find those is to set y equal to 0. So back at the original equation here, right here, where you have y, just make that equal to 0. So 0 equals x squared plus 2x minus 8. And so if you have this equation on its own, you've probably seen this in a problem where it says solve. More importantly, it might even say solve by factoring. So that's kind of a key thing here. We're going to factor this. All right, we're going to split up our x squared. We're going to split up the negative 8 so that we can multiply to negative 8 and add up to positive 2. So positive 4, negative 2. Yep, that works. And once we got it factored, we're going to set our factors equal to 0. And so you get subtracting 4 here, x equals negative 4. Adding 2 here, you're going to get x equals 2. So your x-intercepts are going to be the points negative 4, 0, and 2, 0. So there are my 2 x-intercepts, or better known as zeros. And rolling right along, if you find your x-intercepts by setting y equal to 0, you're going to find your y-intercepts by setting x equal to 0. So in that original equation, and I'm going to kind of pinch, and I know I'm zooming in and out here as I do this problem, but in this original equation, anywhere I have an x, so x right here and x right here, I'm going to replace it with 0. So that's going to be y is equal to 0 squared plus 2 times 0 minus 8. I'm going to zoom in on that so you can really see that part. Do a little more evaluating here. 0 squared is 0. 2 times 0 is 0. And I have a minus 8 at the end. So 0 plus 0 minus 8. My y-intercept is going to be the x value of 0 and the y value of negative 8. So there is my y-intercept. And so at this point, I know I'm asking for domain and range as well, but I'm going to put those on pause for a second, and I am going to take a moment. I'm going to graph my vertex. I'm going to graph my 2x-intercepts. I'm going to graph my y-intercept and the line of symmetry. That axis of symmetry is a line. I've given you a fabulous graph here. Okay, so let's start with our vertex. So from the origin here, we're going to go 1 to the left, so -1, and then down to -9. So there's going to be a point right here. Let's see. Axis symmetry I'll get to in a minute. So my zeros, -4, 0, so on the x-axis, and then 2, 0, also on the x-axis. And we have a y-intercept of 0, -8, which would be right there. So your axis symmetry, that is a dotted or a dashed line that goes through that vertex, okay, through the vertex right there. And here's what I mean about it being the symmetrical piece. So if you notice that this x-intercept over here is 3 units to the right of the axis symmetry, and then this x-intercept is 3 units to the left, that's the whole concept. Every point on the left side is going to have a mirrored point on the right side. And the basic shape here is a U-shaped curve. And the big thing is, yes, it should be curved as best you can. So it looks something like that. Okay, not looking for absolute perfection here, but definitely want that basic shape. And that's going to lead us into the last 2 pieces here, which are domain and range. So domain for a polynomial function, quadratic specifically here, is going to be everything, right? Meaning every value for x is possible, all right? So domain is your input. It's what you put into the function for x, and there are no restrictions. Graphically, if you're trying to figure out what the graph is for domain, or the domain from the graph, you're going to be looking how far to the left does this graph ever go? And as we go up, this graph is continuing to move further and further to the left. So there's no boundary or no limit there. And then how far to the right does this graph ever go? And again, as you're going up, this graph, this parabola is getting wider and wider and wider without limit. So that gets us that domain of -infinity to infinity. Range are your possible y values, the outputs for the function. So while we can put everything in for x, you do not get everything out for y. And the boundary point is going to be your vertex right here. In this case, your vertex is a low point. This is the lowest your graph will ever get to. So for your range, -9 is the lowest value. And then how high does this graph go? It goes to infinity. So we would talk about -9 to infinity. That range would have a bracket on the -9 because there is a point right here where your graph has that value of -9. So that is the domain, the range, the x-intercepts, y-intercepts, the axis symmetry, and the vertexes, all the things, and the pretty little graph. So I'm going to go ahead and make 3 other videos for each one of the other problems on this note sheet. Use what you need. As always, feel free to ask me any questions or concerns, and I will see you in the next one.